Okay, welcome homeowners and future electricians to another episode of Homeowners Electrical Professor. My name is Paul Espasti. I am your host. In this episode, we're going to talk a little bit more about grounding, okay? That is what we're discussing now. This here is a little mock-up of a circuit that you might find in your house where we have here a switch, we have a light fixture up here, we have a receptacle here, another receptacle over there. As you can see here, I've got 3 black wires, 3 white wires, which means that I have 3 14-2 NM cables coming into here. This box over here, we only have 2 NM cables. We have 1 NM cable, black and white, and same thing over here, 1 cable. Now, I discussed before, when you have more than 1 cable that comes into a box, all of the ground wires have to be twisted together. So here I twisted the 2 grounding conductors together, and I have my tail coming out of this wire nut. Same thing right here, I have a tail to attach to my device, whether it's a switch, receptacle, or a light fixture. Now, so that means that in between all of these ground wires, we have 0 resistance, or we have continuity. Now, before I go any further, I just have to tell you that it is imperative that when you're doing this, even though I have wire nuts on everything, that before you open these devices up, you want to make sure that the electricity is off. Now, in my using electrical testers videos, I showed you how to use a non-contact tester. Now I can come over here and all of my conductors, everything is dead. There's no electricity because if you're on the resistance mode and you have electric available and you try to test, you could do damage to yourself and to your tester. So electricity is off. It is imperative that you do that. So now I have here my Klein tester that I showed you before. And if I touch the 2 leads together, so you can see the digital meter goes to 0, which means I have no resistance here, or I have continuity. Remember, I introduced that term, continuity. So what I'm going to do now is untwist my leads here. And if I touch 1 to here and 1 up to here, as you can see here, the meter goes down to 0, okay? Sometimes the numbers will fluctuate if you don't hold it exactly tight. Now, same thing over here, these 2 wires, I've got 0 resistance or continuity. Same thing over here, let me get out of the way. That goes to 0, okay? So I have continuity between all these bare ground wires. Now, if you remember, I also showed you, if you don't want to spend $80 or whatever these Klein tools cost nowadays, I went to Walmart and bought this one. Now, this here is not digital. It has a deflection on it where the needle will go from infinite amount of resistance to over on the, if you follow the green scale on this side, it goes to 0. So when I touch my leads together, I have 0 ohms. And the same thing will happen here. I'm going to touch this conductor and this conductor. There we go. Now my needle goes all the way to 0. I'm going to come over on this side and I'm going to go between this conductor and this conductor. And as you can see, my needle deflects all the way to 0. Same thing here. We have 0 resistance between all of these, just like I showed you on the whiteboard before, where there's 0 resistance, and then one of these cables will go back to your electrical panel, so there's 0 resistance from here all the way back. That's part of what I'll go into more detail with circuit breakers. This here is your for fault current, okay? All right, so anyway, that's basically just a small representation in your house. Of course, there could be a lot more devices on one. This is all on one particular circuit breaker.